Someone is talking to you right now, and before they finish their sentence, some part of you already knows they are lying. You cannot point to the exact word that gave it away, and if pressed, you might not even be able to explain why you feel it. But the feeling arrives anyway, sitting low in your stomach like a held breath. You call it a gut feeling or intuition or just a hunch, but the real answer is far stranger than any of those words suggest. Your brain has been running a deception detection system since before you had language to describe it, and it is faster, older, and more accurate than you have ever given it credit for. Think about the last time this happened to you. Maybe a friend told you they were fine when they clearly were not, or a coworker gave an explanation for being late that technically made sense but somehow did not sit right, or a partner answered a simple question just a half-second too quickly, with just a little too much detail, and something in you flinched before your conscious mind had even finished processing the words. What was that flinch? Where did it come from, and why does it show up before you have consciously analyzed a single fact? To understand what is happening in that moment, you have to go back much further than the conversation itself, back past childhood, past language, past even the earliest human societies, to a time when detecting deception was not a matter of social awkwardness, but a matter of survival. For most of human history, your ancestors lived in small, tightly interdependent groups where trust was not an abstract virtue, but a resource as essential as food or water. If someone in your group lied to you about where the predators were, or about how much food remained, or about who was sleeping with whose partner, the cost was not embarrassment. The cost could be your life, or the life of your children. So the question your brain has been quietly asking, underneath every conversation you have ever had, is not, does this feel true, but something closer to, can I survive believing this? That question runs so deep and so fast that most of what your brain does to answer it never reaches your conscious awareness at all. And this is where the story gets genuinely strange, because the very thing that makes lie detection feel like a mystery, that sense of, I just knew, is not a flaw in your reasoning. It is evidence that an entire second reasoning system inside your skull has already finished its work before your first system even started. Consider how strange this actually is, once you sit with it for a moment. In almost every other domain of thought, you trust conclusions in proportion to how much conscious work went into reaching them. You trust a math answer more if you can show your steps. You trust a decision more if you can list your reasons. But with lie detection, some of the most confident judgments you will ever make arrive with no steps at all, no list of reasons, nothing but a feeling that lands in your body before it lands in your thoughts. Why would your mind be built this way, delivering its most important social verdicts without ever showing its work? And why does it so often turn out, days or weeks later, to have been right? You do not need to have studied psychology to have felt this. You have almost certainly experienced the reverse version of it too, the moment where you ignored that early flicker of unease, because you could not justify it logically, only to find out later that the flicker had been correct the entire time. That gap, between what you felt and what you could explain, is not a coincidence, and it is not mysticism. It is the visible edge of a genuinely ancient piece of cognitive machinery, one that has been quietly running in the background of every relationship you have ever had. Here is the reframe you need to sit with for a moment. You are not one thinker. You are at least two. There is the conscious, deliberate, sentence-by-sentence part of you that listens to words and tries to evaluate whether they add up logically. And there is a much older, much faster part of you that is simultaneously tracking tone, timing, facial micro-movements, posture, breathing, and dozens of other signals you are not even aware you are perceiving. The psychologist Leanne Ten Brinke, working at the University of California, Berkeley, ran a series of studies specifically designed to test whether people are better at detecting lies unconsciously than they are consciously. In her research, participants watched videos of people either lying or telling the truth about a mock crime, and then researchers measured two different kinds of responses. The first was explicit. Could participants consciously say who was lying? On that measure, people performed barely better than chance, which lines up with decades of frustrating research showing that humans, on average, are not very good at deliberately spotting lies when you simply ask them to guess. But the second measure was implicit, using indirect association tests that tracked how quickly participants linked certain faces with words like honest or dishonest, without having time to consciously deliberate. On that hidden measure, Accuracy jumped dramatically. People's fast, automatic, nonverbal minds were picking up on deception with far more precision than their slow, deliberate verbal minds ever managed. Ten Brinke's work suggested something remarkable. The information needed to detect a lie is often present and processed. It just is not always available to your conscious reasoning in a form you can use. Ten Brinke and her colleagues went further, running additional experiments in which participants were shown footage of people pleading for the return of a missing relative, some of whom, unbeknownst to the public at the time, had actually murdered that relative themselves. Once again, conscious judgments of honesty were unreliable, close to chance, but automatic, indirect measures picked up subtle signals that separated the genuine pleas from the deceptive ones. What made this study so striking was the emotional weight of the material. These were not neutral laboratory statements about a mock crime. They were real, high-stakes, filmed pleas, exactly the kind of high-arousal social situation your ancestors' detection system would have been built for. And even there, the unconscious mind outperformed the conscious one. Doesn't that raise an uncomfortable question about how much you actually know at any given moment that you are not letting yourself know? Why would evolution build a system like that, one that knows something your conscious mind does not? Consider what conscious deliberation costs. It is slow. It requires you to hold information in working memory, weigh it against other information, and produce a verdict. And all of that takes time your ancestors frequently did not have. A rustle in the grass does not wait for you to finish a syllogism. A shift in a rival's face during a resource negotiation does not pause so you can consciously catalog it. Fast, automatic threat and trust assessment had to happen instantly and beneath awareness, because the moments where deception mattered most were often moments of real-time social negotiation, where hesitating to think it through consciously could mean losing the negotiation, missing the warning, or misjudging an ally. So what exactly is this fast system tracking? This is where the historical and scientific deep dive gets interesting, because researchers have spent decades trying to isolate the actual signals that betray deception, and the answers are not always what popular culture tells you to expect. Start with the face. In the 1970s, the psychologist Paul Ekman, then at the University of California, San Francisco, began documenting what he called micro-expressions, fleeting facial movements lasting as little as a 25th of a second, far too fast for conscious perception in real time, yet visible on slowed-down film. Ekman's research grew out of an unexpected place, a study of a psychiatric patient who had concealed her plan to attempt suicide from her doctors by presenting a calm, composed face during a screening interview. When Ekman later reviewed the videotape of that interview in slow motion, he found a flash of overwhelming despair crossing her features for a fraction of a second before she resumed her composed expression. That single frame convinced him that the human face was constantly leaking true emotional states, even when a person was actively trying to suppress them, and that the leakage happened faster than conscious control could catch it. Ekman went on to build the facial action coding system, a taxonomy that broke the face down into dozens of individual muscle movements, and he argued that certain combinations, particularly asymmetries between the two sides of the face, or a mismatch between a smile and the muscles around the eyes, were reliable tells that an expressed emotion was not genuine. A real smile of enjoyment, sometimes called a Duchenne smile after the 19th century French neurologist who first described it, involves the muscles around the eyes and cannot easily be faked on command. When you look at someone whose mouth is smiling, but whose eyes remain flat and unmoved, some part of your brain registers the mismatch even if you never consciously name it, and that mismatch is one of the many inputs feeding your gut feeling that something is off. Ekman's broader argument, developed across decades of cross-cultural research, was that certain emotional expressions are universal, recognizable across radically different societies, with little or no prior contact with one another, suggesting they are not learned social customs, but ancient, hardwired signals shared across the entire human species. He traveled to remote parts of Papua New Guinea in the 1960s to test this idea directly, showing photographs of facial expressions to people who had never seen a film, a magazine, or an outsider's face before, and found that they could still correctly identify emotions like anger, fear, disgust, and happiness at rates far higher than chance. If a facial expression for fear looks essentially the same whether you grew up in a highland village with no outside contact or in a modern city, that expression is not a cultural performance. It is closer to a piece of biological hardware, wired in before culture ever had a chance to shape it, which is exactly why a fleeting, involuntary flash of true emotion can slip past even a practiced liar's deliberate composure. You were never taught to recognize that flash. You simply inherited the capacity to notice it, the same way you inherited the capacity to flinch at a sudden loud noise. But the face is only part of the story, and it is worth pausing here to ask a genuinely important question. If facial micro-expressions were the whole answer, wouldn't professional lie detectors, trained interrogators, and career poker players be nearly perfect at spotting deception? They are not, and that gap between theory and real-world accuracy led other researchers to look elsewhere, at what people say rather than just how their face moves. This is where the work of Bella DePaulo becomes essential to understanding the full picture. DePaulo, a social psychologist who spent much of her career at the University of Virginia and the University of California, Santa Barbara, ran one of the most extensive diary studies ever conducted on ordinary lying. She asked participants to keep detailed daily records of every lie they told over the course of a week, no matter how small, and the results reshaped how psychologists think about deception altogether. DePaulo found that the average person tells somewhere between 1 and 2 lies a day, and the overwhelming majority of these are not the dramatic, high-stakes deceptions of crime dramas, but small social lubricants. Telling a friend you loved a gift you did not, saying you are busy when you simply do not want to go somewhere, agreeing with an opinion you privately disagree with to keep the peace. Why does this matter for your gut feeling about lies? Because it means your brain has an enormous, constantly replenished data set of what small, low-stakes deception actually sounds like, gathered not from rare dramatic betrayals, but from thousands of ordinary daily interactions across your entire life. You have been unconsciously building a statistical model of how truth sounds different from convenient fiction since you were old enough to notice other people's tone of voice, and that model gets updated every single day, whether you are paying attention or not. DePaulo's later research, synthesizing hundreds of studies on the specific behavioral cues associated with lying, delivered a humbling finding. Many of the cues people believe signal lying, like avoiding eye contact or fidgeting, are actually weak or unreliable predictors, appearing only slightly more often in liars than truth-tellers, and sometimes not at all. This raises an uncomfortable question. If the obvious cues are unreliable, what is your gut actually responding to when it flags a lie? The answer, according to later researchers, has less to do with any single fixed signal and more to do with inconsistency, and specifically, inconsistency relative to a person's own established baseline. This is where the work of Aldert Vrij, a professor at the University of Portsmouth in the United Kingdom, becomes crucial. Vrij approached deception from an entirely different angle: cognitive load. His research argued that lying is, fundamentally, harder work for the brain than telling the truth. When you tell the truth, you are simply retrieving a memory and describing it. When you lie, you must invent a plausible account, keep it internally consistent, remember what you have already claimed so you do not contradict yourself later, monitor the listener's reaction to judge whether they are buying it, and simultaneously suppress the truthful account that keeps trying to surface in its place. That is an enormous amount of simultaneous mental work, and Vrij's experiments showed that this extra cognitive burden leaves fingerprints in how people speak. Liars, under this added load, tend to produce answers with fewer perceptual details, meaning they mention fewer specific sensory particulars, like exact sounds, smells, or spatial arrangements, because inventing convincing sensory detail on the spot is cognitively expensive. Liars also tend to structure their accounts in unnaturally chronological order, beginning to end, because that is the easiest structure to maintain without contradiction, whereas people recounting a genuine memory often jump around non-linearly, mentioning a detail out of sequence and circling back, the way real memory actually works. Have you ever noticed that a story that unfolds too neatly, too much like a rehearsed script, feels slightly hollow even when every individual fact checks out? That hollowness is very likely your brain registering exactly the pattern Vrij's research identified: the suspicious smoothness of an account that has been constructed rather than remembered. Think about the last time you asked a child what happened to a broken vase, versus the last time you asked someone about their actual weekend. A truthful account of a weekend tends to be messy. It doubles back on itself. It includes irrelevant details that have nothing to do with proving anything, like the fact that the coffee shop had run out of oat milk, or that a particular song came on the radio at an odd moment. These details cost nothing to include because they were simply there, sitting in memory, retrieved along with everything else. A fabricated account, by contrast, tends to be curiously efficient, containing only the details that serve the story being told, because the liar is not retrieving a memory, they are constructing a case, and cases do not usually include irrelevant testimony. Your gut has been quietly counting these unnecessary tangential details for your entire life, using their presence or absence as one more thread in the larger pattern it is weaving together. Vrad took this a step further with an approach called cognitive load enhancement, deliberately designing interview techniques that increase the mental burden on a person telling their account, such as asking them to tell their story in reverse chronological order. Truthful accounts, drawn from genuine memory, hold up reasonably well, even when told backward, because memory retrieval does not depend heavily on narrative order. Fabricated accounts, by contrast, tend to fall apart under this reversal, because the liar was only holding together a forward-moving script, and forcing them to abandon that script exposes the seams. This single finding reveals something profound about what your gut is actually tracking in everyday conversation. Not the content of what someone says, but the effort visible in how they say it. A hesitation before answering a question that should have an instant, effortless answer. A pause that is slightly too long, or a response that is slightly too fast and too polished, as though rehearsed in advance. Your unconscious mind has been quietly measuring cognitive effort in every conversation you have ever had, comparing it against what effortless truth-telling usually sounds like from that particular person, and flagging the mismatch. That word, that particular person, matters enormously, because one of the most important discoveries in the entire field of deception research overturned the very premise most people start with. Timothy Levine, a communication researcher who has spent decades studying deception at institutions including Michigan State University and the University of Alabama at Birmingham, developed what he calls truth default theory. Levine's central claim is that human beings are not naturally suspicious of one another. Quite the opposite. Your default cognitive setting is to assume that what people tell you is true, and this default is not a bug or a naive weakness. It is a functional necessity. Levine's reasoning is elegant. If you scrutinized every single statement anyone ever made to you with active suspicion, treating every claim as a potential lie requiring verification, ordinary social life would grind to a halt. You would never be able to coordinate a meeting time, follow directions to a new restaurant, or believe a doctor's diagnosis, because functional cooperation depends on a baseline assumption that most people, most of the time, are telling you the truth, which, according to DePaulo's own data, they mostly are, since even frequent small lies still leave the overwhelming majority of daily statements truthful. So why, then, do you sometimes catch a lie before the sentence even finishes? Levine's research suggests the answer lies in a specific and narrow set of circumstances that override your truth default setting. According to his findings, most people are actually reasonably capable of detecting deception, but only when specific contextual triggers are present. A strong prior suspicion, a noticeable and significant deviation from a person's established baseline behavior, or a piece of information that directly contradicts something the person has already told you. In other words, your lie detection system is not running constantly in an active suspicious mode, scanning every conversation for tells. Instead, it runs passively, quietly comparing incoming information against your existing model of the person and the situation, and it only escalates to a conscious, felt sense of suspicion when the mismatch crosses a certain threshold. This explains why you can be fooled for months by someone close to you and then, in a single conversation, feel something shift so sharply it stops you mid-thought. It is not that your detection system suddenly switched on. It is that the accumulated mismatch between what this person usually sounds like and what they sound like right now finally crossed the threshold your unconscious mind had been quietly tracking the entire time. Levine tested this idea using what he called the Park and Levine base rate model, analyzing data across dozens of independent deception studies to show that human accuracy in detecting lies is not fixed at chance, as earlier researchers had assumed, but varies enormously depending on how much relevant contextual information a judge actually has access to. When people are given rich context, prior familiarity, and a comparison point, accuracy climbs well above chance, sometimes dramatically so. When that context is stripped away, accuracy collapses back down toward a coin flip. Isn't it strange that an entire field of research once concluded humans were simply bad at detecting lies, when the real finding was that humans are bad at detecting lies from strangers, in artificial settings, with no history to draw on, which is precisely the condition under which your unconscious system has the least amount of material to work with. Now here is the counterintuitive twist, the part of this story that reframes everything you think you know about lie detection. If your brain is this sophisticated, why are humans, in controlled laboratory studies, asking people to consciously judge strangers as truthful or deceptive, famously bad at it, hovering barely above the 50% accuracy you would expect from a coin flip? The twist is that the laboratory setting itself breaks the very system that makes real-world lie detection work. Remember what Levine's truth default theory and Vrege's cognitive load research both depend on: comparison against a known baseline and context that gives the mismatch meaning. In a typical laboratory experiment, a participant watches a video of a complete stranger they have never met, making a single unfamiliar statement, with no baseline of how that stranger normally behaves, no accumulated history, no stakes, no relationship. You are asking someone's finely tuned pattern recognition system to operate with almost none of the data it actually needs to function. It would be like asking someone to identify a forged signature without ever having seen the real one. Of course, accuracy collapses under those conditions. But that collapse does not mean the underlying system is weak. It means the underlying system was never designed to operate on strangers in a vacuum. It was designed to operate on people you know, over time, against a backdrop of accumulated familiarity, which is precisely the situation the laboratory removes. This is why you can feel almost certain that your best friend of 15 years is lying to you about something small, and be almost completely unable to tell whether a stranger giving a 5-minute testimony on television is being honest. It is not a contradiction. It is the same system, operating correctly in the environment it evolved for, and failing predictably in an environment it never evolved for. Your ancestors were never called upon to judge the honesty of a total stranger they would interact with exactly once. They were called upon, over and over, across a lifetime, to judge the honesty of the same small set of people: family, mates, close allies, rivals within the same tight-knit group. The deception detection system in your brain is, in the deepest sense, a relationship-specific instrument, not a general-purpose lie detector, and understanding that distinction changes how you should think about every gut feeling you have ever had about someone close to you. This also explains a pattern that has puzzled researchers studying professional lie detectors, such as customs officers, police interrogators, and intelligence analysts, people whose entire job is judging the honesty of strangers, often just once, under high pressure, with almost none of the relational history your brain actually depends on. Study after study has found that most of these professionals perform only marginally better than untrained members of the public, despite years of specialized training and thousands of hours of practical experience. At first glance, this seems almost absurd. How can years of professional practice fail to produce meaningfully better lie detection skill? But once you understand that the underlying system was built for repeated interactions with known individuals, not single encounters with strangers, the finding stops being surprising and starts being exactly what you would predict. You cannot train a baseline comparison instrument to work well in a context that permanently denies it a baseline. It would be a little like expecting someone to become an expert at recognizing a friend's forged signature by only ever looking at signatures from people they had never met before. So what does all of this mean for you, today, in the actual conversations you are having? It means the flinch you feel when a partner answers slightly too fast, or a friend's story unfolds a little too smoothly, or a coworker's explanation contains slightly less specific detail than it should, is not superstition. It is the output of a genuinely sophisticated evolutionary instrument, one built from millions of years of your ancestors needing to know, quickly and without the luxury of careful deliberation, whom they could trust with their lives. That instrument is comparing what you are hearing right now against an enormous accumulated model of how this specific person sounds when they are telling you the truth, and it is weighing cognitive effort, structural smoothness, emotional congruence in the face, and dozens of other signals you have never consciously cataloged, all within a fraction of a second, all before your conscious mind has finished parsing the sentence's grammar. It also means you should treat that gut feeling with a particular kind of respect, neither dismissing it as irrational superstition, nor treating it as an infallible lie detector you should act on without further thought. The research is clear that this system works best with people you know well and worst with strangers. Works best when you have an accurate baseline, and worst when someone is a fundamentally unfamiliar quantity, and can be thrown off by simple things like nervousness that has nothing to do with honesty at all, since an anxious truth-teller can trigger many of the same signals as a calm liar. The gut feeling is data, valuable data built from a lifetime of careful, unconscious observation, but like any data, it deserves to be checked rather than blindly obeyed, especially in high-stakes moments, where being wrong carries real cost. Think about how this plays out in the small, ordinary corners of your life. Think about a text message that takes 11 minutes to arrive instead of the usual 30 seconds, and how your mind, without any conscious instruction, begins comparing that gap against a baseline you did not even know you had been building. Think about a coworker who explains a missed deadline with unusually specific detail, more specific than the situation seems to call for, and how something in you leans forward rather than relaxes, precisely because Vrijay's research would predict that excessive, oddly precise detail can be as suspicious as too little. Think about the parent who can tell, from a single word choice over the phone, that their teenager is not where they said they would be, not because of any single damning fact, but because of a subtle shift in rhythm that only becomes visible against years of listening to that same voice describe true things. None of these moments feel like data analysis while they are happening. They feel like knowing. But underneath the feeling of simply knowing is a machine that has been quietly logging baselines for years, waiting for exactly this kind of mismatch. There is also a version of this that works in reverse, and it is worth pausing on, because it changes how you might treat other people's discomfort around you. If your brain is constantly comparing behavior against a baseline, then anyone who is nervous for reasons that have nothing to do with lying, a person with social anxiety, someone speaking a second language under pressure, a person who has simply had a hard day, can trigger some of the very same signals your system associates with deception. Increased hesitation, reduced eye contact, a flatter emotional tone. These can come from fear of being disbelieved just as easily as they can come from an actual lie. This is one of the most important and most overlooked findings across this entire body of research. The innocent, when placed under suspicion, often behave in ways that look remarkably similar to the guilty, simply because both states produce stress, and stress produces many of the same surface behaviors regardless of its source. Doesn't that possibility deserve at least as much respect as the confident certainty of your gut feeling? There is something almost tender in realizing this about yourself. Every time you have ever felt that quiet, wordless unease around someone, some part of you was working on your behalf, long before you knew there was anything to work on, drawing on every previous conversation you have ever had with that person, comparing tone against tone, timing against timing, rhythm against rhythm, trying to protect you the same way it protected your ancestors around a fire, deciding in an instant who could be trusted with the last of the food, or the location of the water, or the safety of a child. That system never stopped running. It simply moved from firelight to fluorescent light, from spoken warnings about predators to a slightly too quick answer over dinner, still doing exactly what it was built to do millions of years ago, listening past the words, to the truth underneath them. This is, in the end, one of the quieter gifts of being a deeply social species. You did not choose to build this system, and you cannot consciously switch it off, because it was never meant to be a decision you make. It was meant to be a constant, background hum of attention running underneath every relationship you form, silently protecting the people you love, and warning you about the people who might do them harm, long before you have the words to explain why. It has been doing this since before your species had words at all, since before fire, since before the first shared meal around a common hearth, and it will keep doing it long after this particular conversation ends, quietly filing away every true thing you hear from the people around you, building the very baseline it will use to catch the next lie before it is even finished being told. So the next time you feel that hunch rise up before someone finishes their sentence, remember what is actually happening underneath it. Your brain has already run the comparison. It has already weighed the effort, the rhythm, the mismatch between face and words, against everything it has ever learned about how this specific person sounds when they are telling you the truth. And long before you consciously decide what to think about what they are saying, some far older, far faster part of you has already decided what it feels.